Welcome to clickmyproject.com. Let we discuss about the process facial image compression using patch ordering based adaptive wavelet transform. Let me see the abstract of the process. Wavelet based image compression process were more commonly used in all types of compression. The images were decomposed using redundant tree-based wavelet transformation (RTBWT). Arithmetic encoding is employed to the decomposed sequences and the values were saved in dictionary. The sparse coding and entropy coding were applied to the decomposed images. The images were reconstructed by reversing the same encoding processes. That is, the arithmetic encoding is reversed and the code is decoded. The overall performances of the processes is measured. The redundant tree-based wavelet transformation, which extends the redundant wavelet transformation to scalar functions defined on high-dimensional data clouds, graphs, and networks. The transformation is obtained by the modifying and implementation of the redundant wavelet transform, which was proposed similarly to the way we modified the decomposition scheme of orthogonal transform. This implementation employs a filter bank decomposition scheme similar to the orthogonal discrete wavelet transformation. However, in each level of this scheme, none of the coefficients are discarded. We add in each decomposition level operators that reorder the approximation coefficients. After the decomposition using wavelet transformation, encoding processes is employed based on arithmetic encoding, and the images were reconstructed by means of dictionary construction from the images. The overall performance of the process is measured in terms of compression ratio. Let me see the flow of the process. First, the input images were selected. Since we select color images, the RGB channels were separated, and for each channels the compression process is employed. So first, for each channel, the sparse encoding processes and arithmetic encoding processes were done. After the channel separation in the sparse encoding, the zero elements or the null elements which is present in the channels were eliminated. After that, the sparse encoding is converted into a encoded format of the input image, which is based on arithmetic encoding processes. The encoding of each color channels results in the production of single row values that contains the encoded bits of the input image. In the training processes, the dictionary is constructed. Dictionary construction refers to the identification of the formation of the original pixel informations. So for that, some training samples were taken, and the decomposition is applied, which is based on RTBWT decomposition, and arithmetic encoding is applied to the decomposed bits, and they were saved in the dataset as in the format of a dictionary. Here the dictionary formation refers to preserving of the image data bits in the single array of values. After that, this process is the reconstruction processes. So the coded bits of the input images were obtained, and these coded bits were used for the reconstruction of the images. So for each images, for the reconstruction of them, each images contains some specific mean values for them, and based on them the training images were matched to be of the same mean value with which the input image has. After the matching, the image bits that are similar to the input image decomposed bits were identified. They were then reconstructed. In the reconstruction process, the obtained bits will be in the form of the decomposed RTBWT, and the inversion process is applied to the decomposed coefficients, and finally the performance of the process is measured in terms of the compression ratio and other performance matrices. Let me see the execution of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface for the execution of the process. First, select any one of the input image from the dataset. So the input image has been selected. For the images which is in the dataset, the dictionary has been constructed. Hence, the process will execute for the images in the datasets. After that, the sparse coding is applied to the input image, and the sparse values for each image will be displayed here in the tables. This process will take some time for the execution, and after the sparse coding has been created, arithmetic codes has been created for the obtained images in the three different color channels. The arithmetic coding of the input images converts the images into sequence of bits in order to make it easier for the transmission of the data. The arithmetic codes were created and they will be displayed here. This process will take some time for execution. After the arithmetic codes has been created, the wavelet coefficients were obtained from the arithmetic codes comparing with the dictionary. So this is the final wavelet coefficients obtained for the input image which is preserved in the dictionary. Based on it, the image is reconstructed. Finally, we measure the performances of the processes in terms of compression ratio, MSE, PSNR and SSIM. Thus, we have compressed and reconstructed the images based on sparse and arithmetic encoding, which is preserved in the decomposed wavelet coefficients obtained in the images. Thank you.